My name is Arvind, and I'm joined with my teammate Abdulaziz. And today we're going to be presenting our pitch for our product, which is smart glasses for visually impaired individuals. Let's start. Okay, so these are our table of contents, and this is what we'll be talking to in our pitch, starting from problem solution, aims, objective, working principle, target consumers, value proposition, market potential, sustainability, and our future plans. Okay, so problem and solution. So, what is the major problem and why we had to come up with a solution by creating the smart glasses? So, as we know, visually impaired users face difficulty in navigating and accessing visual information independently. So, since people nowadays have a problem with their sight, they can't do certain things. For example, blind people cannot walk effectively by themselves and cannot cross properly, or people like who are elderly cannot have like a very short-sighted and they can't see clearly. So we are trying to create a product that helps solve these issues. So our solution is to create a smart wearable system which helps in integrating object detection, text reading, scene captioning, and other assistive features. So and part of our solution is we want to make sure it is fully hands-free, because the current like tools that assist blind people, for example, a walking cane, cannot really help the users be hands-free because they're controlling physically. So a voice controlled or a hands-free operation would be like using TTS, which is text to speech module in our product. Goals and objectives. Aim. The aim of this project is to design and develop the smart VR glasses that assist visually impaired users with obstacle detection, object recognition, text reading, and GPS navigation and other assistive features, while making use of AI and sensor integration. Our objectives: design a compact wearable architecture integrating cameras, sensors, and Raspberry Pi, developed an AI and sensor-based modules for real-time object text and navigation assistance. And our last and final objective is evaluate the system performance through user testing and focusing on accuracy and comfort and usability. We want to make sure that the glasses gives the most accurate values, which helps the users and assist them properly without any errors. Now, the working principle. So the working principle has been divided into 5 parts. First is the hardware and design. So we know that with the budget, we can't design a full product to be like glasses. So we got our inspiration from a VR headset. So we built the whole product from by using Raspberry Pi, and our camera is we're using a Raspberry Pi AI camera, which in together works with an ultrasonic sensor, and the user will have audio via Bluetooth. And it's mounted on a lightweight frame which has been 3D printed. And like I mentioned, it was inspired by a VR headset, which helps ensuring portability, stability, comfortability, and comfort. The second is voice control model switching. So, like I mentioned earlier, we want to make sure the user has a hands-free interaction when they're using our product. So, by making use of TTS or speech to text, we can give that hands-free interaction. So the user would be able to switch between modes hands-free without a use of a button or by using their hands. So, for example, the user says open text recognition, the text recognition function will open. If the user wants to open object detection model open. Next is our AI model. So object detection avoidance is a very crucial part of our glasses because it's going to be the main module that helps the user navigate through a busy crowd or in their daily life. So firstly, we also use something known as Azure Computer Vision API, which helps us to do scenery detection. So if the user wants us to capture a certain scenery and it to be explained, he can do it using this feature. And then we have OCR. So for example, OCR can be used to read stop signs or any like important signs, for example, exits or like road signs, or for example, danger signs. So we have implemented OCR, which also stands for optical character recognition. We also have created an object detection powered by our AI camera, like I mentioned, which is an IMX 500, and we had pre-trained data sets, which are Coco data sets. So we took a data set that has all the general uh, data sets of today's thing, for example, a person, a chair, a table, something which a blind person will come across in his come across in his or her daily life every day. Then the fourth is assistive features. So we wanted to add like small assistive features to assist them on their daily life. For example, checking date and time, checking for their schedule, and also setting reminders. Who knows? Maybe an elderly person might have the habit of forgetting things. So having a reminder feature that helps her or him to set reminders, for example, taking their medicine or going to bed early and so on. Then the system flow. So basically, how the whole flow works is the loop will continuously, we have a main loop which connects to all the function like I listed before, and the loop will be listening for the user's voice. And based off what the user says, he will be directed to that function. So if the user says it's now open text recognition, it's going to open text recognition, and the user will have to wait to give the system either the word activate or exit to tell it whether to take a picture or not. And similar, the user can close the text recognition and open object detection, and object detection will tell the user if a person is close to him or any object next to him. Same thing. So now I'll pass it on for the pitch, which talks about market potential and so on, sustainability, to my teammate Aziz.
Thank you, Arvin. So now that we've seen what the smart glasses can do, let's talk about what they're really for. So I'll start off with our target consumers. So first and foremost, these glasses are designed for visually impaired individuals who face daily challenges navigating safely and independently, whether they're walking to work or crossing streets and so on. Our system helps provide real-time awareness of their surroundings. And they're a great solution for elderly people as well with declining vision. It can help prevent accidents and improve confidence while walking. With our features, we provide seamless interactions for visually impaired to navigate and to go around open environments. Now, on the next slide, we talk about the value proposition. So, what makes our glasses different? Now, the three main components, which is the cost, material, and features. Now, for the cost, it's affordable and it uses cheap components. And also with the use of 3D printed techniques and printed materials, which is accessible. Now, for materials, as I said, it's 3D printed materials. They're easy to make and environmental friendly because we're using a biodegradable filament. And now lastly, for the features, with the use of combinations and integration of several tools and techniques, such as what Arvin just said, obstacle avoidance, scenery description, text recognition, and so on, it provides our user-friendly and a variety of options to navigate, so on. Now for the next slide, which is the market potential and impact, the first I'd like to talk about is the visually impaired individuals. Now there are millions of visually impaired individuals around the world. A number of them are blind, including the declining vision of the elderly people. So that's a good market potential area to cover. And now for the accessibility, the access to smart assistive tools remain limited, especially in low and middle income countries. Now, lastly, is the increased demand. So, the global assistive technology market is driven by rising demand for wearable tech, AI integration, and digital health solution, which is we can cover it with our glasses, smart glasses. Now, however, most exciting solutions are either expensive, rely heavily on internet connectivity, or lack real-time adaptability, which we've proven that ours is cheap and so on. Now, the next one I'd like to talk about is the sustainability and the SDGs. Now, before I go into the SDGs, I'd like to talk quick about the sustainability. And the wearable enclosure for the hardware component is designed using 3D printed filaments that is biodegradable, as I've said, reducing the manufacturing waste. Now, to start off on the three SDGs, the first one I'll cover is the well-being and good health. Now, the system enhances the physical and mental well-being of the visually impaired individual and making it more safe to navigate open areas with reduced risk. Now, the next one, which is SDG 9, industry, innovation, and infrastructure. How ours apply to this is because the project embodies technological innovation by the application of AI, IoT principles, 3D printed, and embedded system in a scalable and cost-effective assistive device. Now, lastly, the last SDG, which is 10, It reduces inequality. So, by providing an affordable and accessible and a user centered mobility solution, the project identifies an immediate inequality faced by visually impaired individuals. Now, lastly, the last thing I'd like to cover is the future plans. Now, there's a couple of things that we could do to better improve our product, which is listed here. The three main parts are making it more compact, um, indoors navigation, and multilingualism. Now, for more compact, we decided to redesign the hardware layout to reduce weight and bulk, improving the long-term comfort for the user. Now, for indoors navigation, we can integrate LiDAR and IMU sensors to enable precise room level mapping and pathfinding without GPS reliance. Now, lastly, multilingualism, adding support for multiple languages in both voice recognition and text to speech output to cater to diverse user bases. Now, that's pretty much it for our pitch video, and thanks for watching.
Thank you.
Hello, my name is Muhammad Azim Khidr, and I'm a mechatronics engineering student.
Hi, my name is Arvind Sandarajan and I'm from computer engineering.
Hello, my name is Damian Etienne Enista. I am a Triple E student.
My name is Abdulaziz Usama, and I'm majoring in electrical and electronics engineering.
System is ready. Say a command.
Okay. Wait.
Say a command like open text recognition.
Object.
Opening object detection.
Can you see?
Yep.
Okay. Is it same person?
Yes.
Okay, that's sound detection. Okay. Now Asim, can you understand where you are?
I'm a bit far. I'm looking to your direction.
Okay, walk towards you now.
Person is
Okay,
close.
same person is close.
Person is close.
What to say? Nothing here, so I can walk this way. But then if I turn, nothing. So that's is it saying fridge? Check.
Okay. And
Probably to the
Person is
Yes.
close.
refrigerator, yep. Okay.
Can I walk towards Asim?
Person is
Person is
close.
close. Okay. Now move.
Person is close.
Yeah, there's no one here now.
Again. Say a command like open text recognition.
Open text recognition. I did not supposed to touch it.
Text recognition mode activated. Say activate to take a picture or exit to return.
Activate.
Image captured. Reading text. This is a smart glass. I see the text.
Picture.
Opening image captioning mode. Say activate to take a picture or exit to go back.
Activate.
Caption. A person holding a sign. Step 1. Leave. Step 2. At the roundabout, take the first exit. Step 3. Bear left, Lebaraya, Bukit Jalil, 213. Step 4. Turn left. Step 5. Turn right. Step 6. Turn left. Step 7. Turn right. Step 8. Turn right. Step 9. Turn left. Step 10. At the roundabout, take the second exit. Step 11. You have arrived. What would you like to do?
Time.
Today is Saturday,
Schedule.
Today is Saturday. You have capstone meetings in the morning and time for self-study or coding in the afternoon. What would you like to do?
Reminder.
What should I remind you about?
Taking meds.
At what time should I remind you? Say something like 9, 10 a.m. or 5 p.m.
23:07.
Okay, LL remind you to taking med at 11:07 p.m. What would you like to do? Reminder, taking med.
Time.
Today is Saturday, April 19th, and the time is 11:07 p.m. What would you like to do?
Quit.